Okay, so just a quick topic overview of what we're going to do today. We'll start with some things you do in the preseason, such as the chassis preparation, autonomous movement, and a little off-season game you can create. And also after that, we'll move into things that happen during the season. Main two categories are going to be prototyping and driving. So for prototyping, we'll talk about how to come up with a good idea, and you need your proof of concept, and also bringing it all together. And for the driving, we're going to cover just some strategies that we use to make sure that we can get the most points when we actually go to compete. So talking about the first thing, during your preseason, there's a lot of time you have, but you don't really know what the game is. The best thing you can do is to just prepare for things that always stay the same. So one thing you can do is you can prepare your chassis. The chassis is like the foundation of every robot. So if you can get a chassis ready during the season, you'll be able to base everything off of your foundation. For example, maybe I want to mount a linear slide here. Well, I need to figure out where to mount it. And if you have a chassis ready, this will allow you to be able to picture everything and see how all the building blocks fit together. And so to do this in the off season, many teams, they will experiment with kits, such as you can see the Studica chassis kit. And it really saves you time that you will be spending on developing other things during the season, because there might be some things you want to tweak with the chassis. For example, the torque, what RPM motors you use, the gear ratio. And so doing this during the off season, it'll just give you more time to actually focus on the more season specific tasks. And a piece of advice for building your chassis, use a really large chassis. So if you have the resources, it's good to have a really large chassis and a smaller chassis that you can build a prototype to of your robot. Because with a really large chassis, this will allow you to throw like parts on in a really, it gives you space to put things on, and it removes the headache of making everything packaged well, and it just allows you to get your robot out as quick as you can. So just to go over some couple of examples, as I mentioned before, there was a Studica chassis, and there's also the GoBuilder Strafer chassis. So this is a kit chassis, and GoBuilder provides instructions for these. This is one of the simpler chassis to make, and a lot of teams use these. And so if we take it a step up, a parallel plate chassis. This is a custom chassis. It's usually used with two pieces of aluminum, and it's a bit harder to execute. But if you want to dedicate your time in the off season to make a really good chassis, it's going to help you a lot in the game. For example, you can look at a team, the Indubitables. They spent the entirety of last season working on a really good chassis, and they were able to forget about the chassis during the prototyping of the season and build everything around it. And if you're looking to make one of these, there's many videos online explaining them, and you can also drop in the FTC Discord server where there will be many people wanting to answer your questions. So a more unique chassis is a Swerve chassis. This is less of I'm preparing for the season and more of I want something unique to work on, something that's going to challenge me CAD-wise and code-wise. And this can also be viable during the season, but it also does take a lot of resources to make. So now another thing you can do during the off-season is just creating your autonomous movement library or experimenting with other libraries such as Roadrunner or Pedro Pathing. So the reason why that autonomous movement is so important is on a game standpoint, autonomous points count as double because they're counted once during autonomous and once during teleoff. And to be able to achieve your scoring of your points, you need to be able to drive with precision and speed to grab the things. So during the off season, let's say you already created a chassis, you'll be able to mess around with some of these libraries such as Roadrunner, tune it, figure out how all the pathing works. And when you have your robot complete during the season, you'll be able to just take from your library and just drop them in. It's like you already have the puzzle pieces ready, you just got to fit them together. And to make this work, one thing you may need is a Odometry. So what a Odometry is basically just a dead wheel that's mounted to your robot. And the good thing about that is when crashes occur, the odometry wheels only measure movement when the robot is moving. So this would be an advantage of odometry versus something like just using the encoders of your robot, because these will keep on tracking even if the wheels slip. And one last thing. So let's say you are an experienced team. You've already done a lot of seasons. One thing that our team personally has done is we've created our own off-season game. So as a quick example, last year, we used some of the Fright Frenzy balls and we just got a pallet, put some walls on it, and we create our own game where you have to pick balls and put in the pallet. And what this allows you to do is this is going to really build the entire like build all aspects of your team. For example, the mechanics, they have to work on a new robot. The coders have to figure out how to code Auton and code around the subsystems, make all the timings work. And it'll also give the drivers something to practice on, something to practice their skills on. And so another thing is, if you have a lot of rookies on your team, new team members, you can use this to help train them. So resources such as FTC Sim already exist, but it's better to have something that's more like your actual season. That way it's more realistic. Okay, so now we're going to go into the prototyping phase. So this is when the season comes. So the first thing you should do, always, you have to read the rules. The rule book, let's say last year, going into this season, you're like, wow, I see all these super long robots. I'm just going to make a robot that sits in the center of the field and scores and just has crazy extension. But if you read the rules, you would have realized they added an extension limit this year. And that's just going to kind of stop your ideas. So if you read the rule book, this will allow you to know what you can and can't make and kind of formulate your ideas. So after your entire team has read the rule book, you guys can come together as a team, sit in a circle and just brainstorm ideas. And this can include just taking a whiteboard and everybody comes up with their own idea for a different subsystem. And so after your team has done this, this will be really good because you can split members into individual groups. And when members are in individual groups, they can each work on a specific system, but also work together with other groups to figure out how systems work together. And one key thing that you have to remember is before thinking about making anything, you should develop your game strategy. If you specifically think about how I'm going to intake, but you're forgetting, well, how am I going to outtake after I intake? You have to develop all of your ideas together, figure out how everything works together before jumping in and building something. So to the actual prototyping, after you have your idea, you got to prove that it works. Let's say it's something more advanced, like a sprung intake. You can see over here, this is an example of what we built this season. You want to start with a sketch so you can formulate your ideas on paper. You have an idea of what it'll look like, and then you have to build it out. So you might see a lot of teams use 3D printed parts, 3D print to build their prototype. This can work if it's a design that you know already works, but a really good suggestion is to use kit parts, such as GoBuilder parts or Studio parts. And the advantage of this is it allows you to build your prototype really quickly. You just want to prove that your idea works here. So if you use the kit parts, you don't have to wait for the 3D printers to print. If you messed up on the CAD, you don't have to wait for a reprint. You can just test something, and once you know your idea works, once you know you wanna use this, you can then get to the finer details. Make a more advanced design, make it more compact, use less servos. But for the first prototype, make it as janky as possible. It doesn't matter how big it is, it just has to work. And so after your team has tested a lot of prototypes, like for example, we already have an outtake and a claw. We should throw together a really scrappy robot. So using a really large chassis, you can throw all the parts together. And this doesn't have to be a really compact robot. It doesn't have to be perfect. We just have to see what issues are going to happen, because not all issues can be brought out during only thinking. You have to run testing. So this will also give the coders time to work with your subsystem ideology, and it'll give your drivers time to practice your robot.
Okay, so now on to driving. So our team personally thinks that it's actually a pretty underrated point increaser because so our team focuses mostly on consistency over innovating over a short period of time. So basically there's two driving systems. There's field centric and robot centric. For robot centric, it's good for maneuvering around, and sometimes it's also used for pushing. So for example, last year there was a lot of pathing, so we decided to use field centric as opposed to this year. Robot centric, sorry, as opposed to this year where we use field centric because there was a lot of repeated movements. And yeah, so robot centric is also similar to an RC car, so it might be easier for example, rookies to get onto the driving wheel. For button optimization, they should make sense either logically or optimally. Those are two choices you can go with because logically it's easier for you to understand and therefore easier to practice. Optimally, it's easier with more practice. So there's two methods, depending on the time you have, you can go for either one. And another thing you can do is to have like a communication system for driver one and driver two. So for example, this year, what we did is that because we have two drivers, we have to make more freedom for the buttons. We have two drivers in charge of the vertical slide and the horizontal slide. So this can allow us to have more buttons and therefore have more freedom when driving, and also like it can increase our potential with scoring as well.
And one really key thing with button optimization, the reason why you do this is, let's say you've reached a point where your robot works really well, the code works really well. It's just up to the driver. When you have optimized buttons, it could save like seconds over the entire game. Because if you have to move your fingers off of your game pads to just press a button, over time this adds up. So this is a really fine detail. But if you have optimal buttons, it'll also save you a lot of stress during the game when you don't know how things work.
So for actual practice strategies, what we do is that, for example, this year we have like 60% rookies on our team. So what we did was that we split them into different pairs for teleop practice. And then when we had the Auton coded out, we also incorporated that. So we can also make sure the transition from Auton to teleop is smooth and prepared for competition. What this also allows us to do is to have like a game plan idea and simulation. This is another use for the pre-prepared chassis, because if we have other practices, other chassis, we can use them to simulate defense, as defense is actually a big part of this season's game. And this allows us to have a different game plan. So like what we're gonna do if they push us. What we did is that we found out that driver two, when it's in charge of the horizontal slide, we can also intake at the same time while driver one deals with the defense.
That's all for us today. So we can move on to the Q&A phase now.
I have a question for you guys. Can you hear me?
Yeah, we can hear you.
Yeah.
Okay. What tools or materials do you recommend for efficient prototyping?
So for efficient prototyping, our team is more used to go build up parts, but what you want to make sure is you decide on one manufacturer, because what these manufacturers do is they make sure that all their parts function together. So if you took a go build up part and tried to put it on an Andy Mark part, the holes won't fit. So you should really just decide on one manufacturer and buy different types of parts. And also talking about the parts specifically, some things that are really important. I'm going to talk about go build up parts here, but some things that are really important are your structure parts. So things such as U channels or the flat ones or motor mounts. These allow you to connect things together. And with these parts is also, they'll let you build something that's not just really flimsy. And lastly, something we also use is we use sprockets. So we don't use we use chains. So we don't prefer to use belts because the size for belts vary. But with the chain, you can kind of take a piece off, put a piece on, and this just really allows you to tune it to whatever prototype you want to use, because you want to get something out really quickly and just make sure everything works.
Thank you.
I have a question. How do you balance your time between building, programming, and practice driving?
So as I mentioned, like the way we do it is that at the beginning of the season, we separate into different groups to make different parts. And then when our coders have the Auton finished, we can incorporate that into driver practice. So it's like the driver practice goes in between sometimes.
And something else, so about the full raw prototype. So we don't, a lot of teams do is they try to get the most perfect robot the first attempt. They spend like a couple weeks CADing, a couple weeks building it together and testing the code, and that doesn't really give their drivers time to practice. But what we do is, as I talked about, we try to get the full robot together, because if the ideology of a robot is around the same, we're using the same amount of servos in the same place, it's just not as compact, as optimized, when we get a prototype robot out, it gives our coders time to prepare our entire code, like initialize all the motors, set up everything, get all the motor directions correct. And this also gives our our drivers time to drive while the builders and mechanics are working on the second robot.
Thanks.
I have one more question for you. What is your process for refining driver skills before the competition season begins?
So before the competition season begins, since you can't really work on anything game specific, what we try to emphasize is that the robot, this isn't BattleBots, right? You have to be able to drive around smoothly without crashing. So sometimes what we'll do is we'll set up an obstacle course, and we usually do this using a Go Build a Chassis, because they're generally larger, but they're also easier to control. And it gives us, our drivers, mileage. They get to practice, get a feel for how the driving works. And what we'll also do is with our game simulation, or we can also use last year's game, we can get them to just try seeing how like everything works together. And yeah, so it just really builds on their raw driving skills, but also their communication skills if there's a driver too with them.
Thank you.
I also have one more question. How do you incorporate lessons learned from past season into the preseason preparation?
So in the past seasons, if we make a mistake, for example, one of our main issues last year was that our motors were packaged too high, so the center of gravity was too high. What we do in the preseason is immediately, before the season starts, we're just like, we have to plan everything out for the season in a way that it'll fix our mistakes of the past season. Well, we usually keep track of them in a spreadsheet, things that we should fix. And when before the season, we go over as a team. We'll say, well, we can fix this one like that, and we can identify issues and how to fix them. And over the years, this just allows us to like figure out what works and what doesn't. And what something else is, our more experienced members, they teach these things to the rookies. So the rookies, when they become experienced members, can teach these to the new rookies.
And also with packaging, one of our biggest issues last year was with disconnects. So how we design a robot this year is to have insulated driver hubs and expansion hubs, so that doesn't happen again.